Finally, the memory appenders contents are printed to show recent log history. The demo shows messages at different levels, formatted with arguments, includes an exception stack trace, demonstrates dynamic level changes and sampling, measures performance, and prints the memory appender contents. At the end, the shutdown hook closes all appenders cleanly. This is the same architecture used by Log4j and LogBack, just implemented in a single, readable Java class. You can now customize it for your own projects, add new appenders like a socket appender for remote logging, or integrate it with monitoring systems. Understanding how logging works from the inside out will make you a better developer and give you full control over your application's observability. We start by defining two enumerations. Level defines 6 severity levels: trace, debug, info, warn, error, and fatal, each with a numeric severity for comparison and an ANSI color code for console output. Format defines 3 output formats: plain text, JSON for machine parsing, and XML for enterprise integration. Appender type enumerates the destinations where logs can be sent: console, file, rolling file, socket, and an in-memory buffer. These enums provide type safety and clarity throughout the framework. Log event is the immutable data carrier that represents a single log entry. It contains the level, message, logger name, caller location, class name, method name, and line number captured from the stack trace, timestamp in milliseconds, thread name, a copy of the MDC context, an optional marker for filtering, and an optional throwable for exception logging. We use the builder pattern so that different parts of the framework can construct events with only the fields they need. The builder provides fluent setter methods, and the build method creates the final immutable event. The MDC class provides thread local storage for contextual information like user IDs, session IDs, and request IDs. It uses Java's thread local to isolate context per thread, which is essential in multi-threaded servers. The static methods put, get, remove, and clear allow application code to set context at the beginning of a request and clear it at the end. The copy method returns a snapshot of the current context, which the logger captures into each log event. Appenders are the output destinations for log events. We define an appender interface that extends autoclosable and requires 3 methods: append, log event, to write an event, get name, for identification, and set format, to change the output format. Every appender implementation, console, file, rolling file, socket, or memory, conforms to this interface. This makes the framework extensible. You can add new appenders without modifying existing code. The console appender writes log events to standard output with ANSI color codes. Its append method formats the event using the current format, plain, JSON, or XML, wraps it in the appropriate ANSI color for the log level, and prints it. The output is synchronized on system.out to prevent interleaving from multiple threads. A reset code restores the terminal color after each line. This appender is perfect for development and debugging, giving immediate visual feedback with color-coded severity. The file appender writes log events to a file on disk. It creates the parent directories if needed and opens a buffered writer in append mode. The append method formats the event and writes it as a line, flushing after each write to ensure durability. The file is never rotated, it grows indefinitely. This appender is suitable for simple applications or when another process handles log rotation externally. The rolling file appender extends the file concept with automatic rotation. When the current log file reaches a maximum size, the appender renames existing files by shifting them. File.log becomes file.log.1, file.log.1 becomes file.log.2, and so on, and creates a fresh file. The number of backups is configurable. This prevents disk exhaustion and makes log management easier. The append method checks the current file size before each write and triggers rotation when the threshold is exceeded. The memory appender stores recent log messages in an in-memory deque with a configurable capacity. When the capacity is exceeded, the oldest messages are evicted. This is useful for displaying recent logs in a UI dashboard or for debugging where you need quick access to the last few events without reading a file. The getMessages method returns a snapshot of the current messages. 3 formatting methods convert a log event into a string. The toPlain method produces human-readable output with timestamp, level, thread name, logger name, message, marker, MDC, and optional stack trace. The toJSON method produces a structured JSON object with all fields properly escaped. The toXML method wraps the event in an XML element with attributes. These formatters are used by every appender, and the choice of format is configurable per appender. The escape methods handle special characters to prevent injection or broken output. Logger is the primary API that application code interacts with. Each logger has a name, usually the class or package name, a minimum level, a list of appenders, and optional sampling. The log method checks if the event's level meets the threshold, applies sampling if configured, formats the message with string.formatStyle arguments, captures the caller's location from the stack trace, builds a log event with all available context, and sends it to every attached appender. Log Manager is the central registry for loggers. It maintains a map of named loggers, creates them on demand, and applies global settings. A root logger exists by default with a console appender. getLogger returns an existing logger or creates one with the current global level and all global appenders. setGlobalLevel changes the level on all loggers simultaneously, enabling dynamic reconfiguration at runtime. addGlobalAppender attaches a new appender to every existing and future logger. A shutdown hook ensures all appenders are closed when the JVM exits. The main method demonstrates every feature of the framework. It creates 3 loggers for different components of a simulated application. A file appender with JSON format is added globally so all loggers write structured logs to disk. A memory appender captures the last 10 messages for inspection. MDC context is set with a user ID, session ID, and request ID. Basic log messages are emitted at various levels, showing how different severities appear. Finally, the memory appender's contents are printed to show recent log history. The demo shows messages at different levels, formatted with arguments, includes an exception stack trace, demonstrates dynamic level changes and sampling, measures performance, and prints the memory appender contents. At the end, the shutdown hook closes all appenders cleanly. This is the same architecture used by Log4j and LogBack, just implemented in a single, readable Java class. You can now customize it for your own projects, add new appenders like a socket appender for remote logging, or integrate it with monitoring systems. Understanding how logging works from the inside out will make you a better developer and give you full control over your application's observability.